All right, so here we are. So 6.1. So we're talking about factoring out the greatest common factor from a polynomial. So the question is, the 4x plus 12, they want me to factor it. Now, what does that mean, factor? Factor. Factor means unmultiply, is what you could say. No, they're saying, what was it before it was multiplied? They're saying, there was something out here. Whoops, I'm not writing that too neatly. They're saying there was something out here. There was a plus sign in here. I'm not the neatest writer. Let me try again. There's something out here. And there were two things in there. So what was out here and what two things were in there that would multiply to be 4x plus 12? You know, whatever's out here goes boom and multiplies these, and it goes back to 4x plus 12. So how do you find, first off, what goes out here? It's called the GCF. What does GCF stand for? Greatest common factor. I'm not going to quiz you on the names, but greatest common factor. Basically, it's what goes into 4 and 12. So what goes into 4 and 12? 4 does. Now 2 does also. And 1 goes into everything. So how do you know which one you want? Why wouldn't we use 2? Why are we going to use 4? Greatest. Yeah. So you pick the biggest number that goes into both of them. The greatest. So 4 is the biggest number that goes into 4 and 12, right? So that's what goes on the outside. It's the greatest thing they have in common. And now, how do you figure out what goes on the inside?
You're going to multiply 4.
Yeah, whatever works. Huh? Yeah, you're thinking multiply. Good, yeah. So 4 times what would go back to 4x? Well, just x. And then we're just thinking about distribution. 4 times what would go back to 12? 3. And that's it. We're done. That's the answer. What did we do? We just unmultiplied it. That's what factoring is. Just find out what it was before it was multiplied. And it might seem like a weird thing to do, but it's useful. We'll see next week. Questions on that? Feel free to speak up. Okay. So, more factoring. So, just like number 1, we want to first off take out what's in common. So, you know what we're going to do, right? We're going to do parentheses, something on the outside, 2 things on the inside. So, let me give you a second. You want to look at this and this. There's no number they have in common. Like, there's not a number in front of the x to the 8. If there was something like a 14 in front, then I would take out 7 because, 7 would go into 14 and 7. But there's not. There's no number. So forget that. Well, what do we do about the x's with the powers then? Which one do we take out? The bigger one or the smaller one? It says greatest common factor, doesn't it? But I'm trying to trick you. It's actually the small one. Now why? Why does it say greatest common factor? See, math is just tricky. It makes no sense. No, it does make sense. Think for a minute. What if I had a friend that had 7 dogs and another friend that had 8 dogs? How many dogs do they have in common? 7. That's the most they both have, isn't it? See, the lower number is the most, right? Do they both have at least 1 dog? Yeah. 2, 3, 4, 5, 6, 7. 7 is the most they both have. 8 they don't both have, right? So the greatest amount in common is the lower number. That's actually reasonable, isn't it? So yeah, so when it comes to powers, you take the lower one. Let me write that. So when it comes to powers, you take the lowest. So that would be x to the 7th. Does that make sense? If you had x to the 3rd and x to the 5th, you would take out the x to the 3rd. Because that's the most they have in common. It's the lower one. Put that out there. Now what goes on the inside? Whatever works, huh? Boom, boom. X, yeah, just plain x, huh? Because if you write just plain x, what power is really there? Invisible 1 is really there. Powers add, that'll go back to x to the 8th. The other one is a plain 7, because that'll multiply to go back. Is that good? Is that making sense? So that's what we type into Math Excel. Just doing your homework. When you do yours, it'll be the same problems, just different numbers. The same. So write down, or it's also going to be recorded on YouTube for you. But write down the problem numbers, because when you go to do your homework, problem 3 will be just like this with different numbers. Same problem numbers. Number 3 will be similar to number 3 in your number. All right, so if you look at 243 and 75, what goes into those 2 numbers? I have no idea. You don't need to know those. You can use calculator. You can use calculators for everything. Homework, tests, everything. So how do we use our calculator to find out what goes into 75 and 243? We just kind of start guessing at things, really. So 243, 75. Let me try dividing by some things. I know 3 goes into that guy, right? And 3 goes into that guy. Divide them both by 3. Is it 81 and 25? And that's it, huh? 3 is what goes into both those. How did I know that? Well, I just looked at the 3 at the end of 2. But just try stuff in your calculator. How do you know nothing bigger goes in? Because what's left, 81 and 25, has nothing more in common. So 3 is all there is. And there can't be any more commonness, or 81 and 25 would have stuff in common. So 3 is going to come out. Now, do we do any letters along with the 3? Look at what they have. Do they both have a y? No. So y is not in common. Do they both have an x? Yeah. So what do I take out? Plain x or x squared? Plain x. The lower one, remember? They both have plain x. They don't both have x squared. The greatest amount they have in common is plain x. 3x goes into both of them, doesn't it? It's what they have in common. Now, we're going to put a minus. This one has minus in the middle. What goes on the inside? When you multiply letter number things, remember how it works from your earlier algebra stuff? Out front numbers multiply, powers add. Out front numbers multiply, powers add. So, 3x times what? 81 and the y, because we know over here, divided by 3, 3 times 81 is 243. And then 3x times what? We need 25, because 3 times 25. And what? X, because the invisible 1 adds up to be 2, doesn't it? If there's no power showing, it's an invisible 1. And there it is. It's factored. Good. Yeah?
On an exam, can we use calculators?
Yep, absolutely. You can use exams on everything. Calculators on everything. Okay. So there we go. So it's 3 of them, but it's the same deal. Give that a try. Take out what's in common. Start with the number. What number, don't say it out loud, give everybody a chance to think about it, but what number goes into 14, 10, and 4? Think about that, write it on your own paper. And then ask yourself, do they all have an X? What's the lowest one? That's what comes out in common. So what number goes into 14, 10, and 4? 2. And then what do I do with the letters? They all have an X, right? So I take the lowest one, which is just a plain X. Now there's going to be 3 things in here. The first 2 are separated by a minus, and the last 2 by a plus. Good so far? So I took out what's in common. And now ask yourself what works. 2x times what? We'll go back to 14x cubed. Remember, out front numbers multiply, powers add. So what do I need? 7. 2 times 7 will go back to 14. X squared, because this is an invisible 1. Powers all right. Out front numbers multiply, powers add. So that's, so far so good. Middle?
5x.
5 and x, huh? Because again, the invisible 1, powers add, that'll go back. And the last one? 2. And there we go. Good. Stop me if you want to talk about it.
Can you explain that, the powers add deal that you keep mentioning?
So I'm talking about that rule. If you have like 3x to the 7th multiplying, let's say 5x to the 4th, what happens is out front numbers multiply 3 times 5 is 15, and the powers add, that'd be x to the 11th.
Okay.
Yeah, that's the rule for multiplying letter number things. Out front numbers multiply, powers add. Yeah. Why do they do that? Why do powers add? Who says so? Some math teacher? Some math book? I like to do that every now and then. Just talk about why. I don't want math to seem like magic to you. I know it is for a lot of people. They think it's just some kind of weird magic stuff. It's not. Math is just logic. Let me show you what I mean. Why do powers add? Will you tell me? X to the 7th, x to the 4th. What does x to the 7th really mean? I mean, what is it really? Yeah, what's that little number in the upper right-hand corner mean? 7 of those, huh? So that's 7 x's, 4, 5, 6, 7. And what does that really mean? 4 of them. So how many x's you got? course the powers add. That's just logical. That's just true, isn't it? That's all math is just following the pattern of truth. Okay. I'd like to do a couple and skip and just do the harder ones, but these are worth doing. Try that one. So take out the number that's in common and then the letters. All right, so what goes into all three of those? What number? 3. Yeah, 3 goes in those. Check your calculator. If you're rusty on some of those times tables, just use your calculator. 18 and 15 do divide by 3 evenly. Now, let's do the x and the y. Do they all have an x?
Yes.
Yeah, they have x in common, so take the lowest one, which is plain x, or x to the first, really. And do they all have a y?
Yes.
What? Right, they do. And what's the lowest one? Plain y. Okay, big old parenthesis, 3 terms in there. Let's see, let's take it from there. Now, 3xy times what? Remember, this is invisible 1 powers on these guys. So what's this going to be? X squared. Yeah, no y at all on that first one, huh? That good? Next one. 6x. Invisible 1 powers add. And then the last one, just 5, huh? No x or y at all. Good enough. Questions? It'll be the same thing for you, just different numbers. All right, are they your favorites? No? I've never heard that before. All right, so let's see, what do they all have in common up there?
4.
Yeah, they have a 4 in the denominator, don't they? And the numerators are like all different, so just 1/4 is the number. And so let's do that first off. So I'm going to take a 1/4. See how they all have a... You might wonder, why did you do 1/4 and not 4? Well, if you just do 4, here's why you would not do just 4. If I write 4 alone, like a whole number 4, do you realize that means over 1? Whole numbers are over 1. Why? Who says so? Well, that's what it means. Remember what a fraction means? Think about 10 over 2. What does 10 divided by 2 equal? 5, right? Because the bottom goes into the top. That's what a fraction means, bottom into top, huh? So 1 goes into 4 times. That proves that the whole number 4 is the same as 4 over 1, which is not the same as 1/4, right? Big difference between 4 pies and 1/4 of a pi, right? Those are different. Okay, so with all that clearly in mind, let's remember that it's 4 in the denominators. So you have to take out 1/4, right? Not 4. Do they all have an x? Yeah, what's the lowest one? Just plain x, huh? First power. All right, what goes on the inside? Whatever works. So the first one's... The first one, second one, third one, fourth one here. So 1/4 x times what would go back to 1/4 x to the 7th? X to the 6th, exactly. Is that good? Because it's invisible 1 power, we'll add on that. All good. And then the next one, 1/4 x times... Now what happened? How do you get back to 3/4 x to the 5th? A hush falls over the crowd. You're not sure?
Plus 1/2.
What do you do with that 3 on the top? How do you get that 3 to go back to the top? Remember what we just saw? A whole number is in the top. So all you got to do is do 3x to the 4th. Because what? That 3 is really over 1. I'm not going to leave it looking that way, but that's what it is. You should have that in your mind. A whole number is really in the top, isn't it? You clear on that? Whole numbers, if you need to see them as a fraction, they're really at the top. They're over 1, aren't they? Why? Because what I just showed you. 1 goes into 3 times. That's just a fancy 3, isn't it? Whole numbers are really in the top, which is where I want it. So that's right. Everybody see that? 1/4 x times 3x to the 4th. That 3 will go to the top. It's 3 over 1. And that's right. How about the last one? Whoop, I skipped one. How about the third one?
I put 5x.
Yeah, the 5 will go to the top, so that's, and then x to the third because the power adds. And the last one, what do I put in the last spot? Just leave it off? Do I put x? Would x be right? Because that would be 1 and 1 and make 2, wouldn't it? It can't be x, because if you just write x, there's an invisible 1 power, and that would add to be 2, and we don't want 2. This is just supposed to go back to 1/4 x. So what do you put there then?
1.
Just a big old 1, huh? You do have to put something. You can't leave a blank. Blank would be 0, and anything times 0 would be 0. That wouldn't work. To get back to the 1/4 x, if you multiplied 1/4 x times 1, it would be 1/4 x, wouldn't it? It's true. Everybody see that? So there's our answer. Can you read that? Sorry, I'm a little scribbly. That's a 3 there. All right. That's a tough one. So remember, whole numbers are in the top, aren't they? A little more challenging. Okay, so, yeah. Rather than, here, I'm going to switch. I know you're probably writing down, but I'll come back to it. Let me build up your understanding to do that one. If if I had yx, what do they have? Okay, if I had yx minus 3x, and they asked me to factor that, you could do that one, huh? That'd be pretty easy for y'all. What do they both have in common? X. They both have regular old x. So you would put what they have there, and then you do the parenthesis, and then what would go on the inside of the parentheses? Y minus 3, huh? Because why? Because that x could go boom and go back, and boom and go back, huh? So y'all could do that one real easy, right? Let's think about, you know what math is at the heart of it? It's patterns. It's just patterns. That really is it. Math is the science of patterns. Learning to watch, predict, describe, do everything well with patterns. Getting better and better and better at following a pattern precisely, exactly. That's math. That's what math teaches you to do more and more, which is useful. What does a doctor do? They look at patterns and symptoms. What does a lawyer do? Patterns on and on and on. So that kind of thinking is beneficial. So think with me about patterns. So what's the pattern we have here? When two terms have something in common, we put it in the front, parenthesis, and then we remove that common thing and just bring down the other pieces. Maybe if I write that, it'll be helpful. So, right? So you say, hey, look, they both have an x, put it in the front, and then gonzo, drop down the other parts. That's the pattern of factoring, huh? So what that means is that pattern is always true, even if they make the problem bigger and uglier. That's when your ability to precisely follow the pattern becomes more important. So for example, like, what do they have? They have that. Okay. So what if instead of yx minus 3x, which is what I just gave you, what if that x is replaced with, what do they have? X plus 1. Parenthesis, x plus 1. Do you see how that's the same pattern? See, it's same thing, same thing. Instead of a plain x, it's a parenthesis x plus 1, parenthesis x plus 1. Whatever. The pattern's the same. It could be a funny monkey. It could be y monkey minus 3 monkey. And we would just say, well, whatever you got, you gotta, I can't draw a monkey. I'll put M. If you got a monkey, you take the monkey in the front, gone, bring down the leftovers, huh? That's the pattern. But instead of monkey, we have parenthesis x plus 1. That's the right answer. Do you see how that's the same exact pattern? It's just bigger and it's got a little parenthesis, whatever. They both have a parenthesis y plus 1. Put it in the front, remove it, drop down the leftovers, huh? Why? Because that parenthesis could go boom, and it could go boom, and it'd be right back, wouldn't it? See how that's the same thing? Now, I know some of you guys are familiar with FOIL. You might think, well, mister, shouldn't that FOIL? Yeah, I know there's another thing there, and we'll get to that. But this is also true, isn't it? That whole thing could go boom, and the whole thing could go boom. And that's proven it's true. Okay, so that's what they're testing you. So you look at this, you go, okay, they both have a parenthesis x plus 1. Remove it, new set of parentheses, bring down the leftovers, y minus 3. We're done. Okay, so that's where we're going now. Let's try another one of those. It's the same pattern. They're giving me negative in the front. They say factor out with negative. So basically when the front term is negative, just take out whatever you have in common that's negative. So right in the front we have negative 5x. So what goes into 5 and 20? 5. But if, so let me just write a note here. Bless you. When the front is negative, factor out negative. And signs change inside the parenthesis. So there's the moral of this story. So basically, I'm going to take out negative 5. Why? Because the front is negative. So if you're doing your factoring thing, taking out what's in common, and the front is negative, when you factor out negative. Instead of regular 5, I did negative 5 because that was what the front was. Now, what goes on the inside? Whatever works. It's always whatever works. Negative 5 times what? We'll go back to negative 5x. Plain old x, huh? And here's the real trick question. Negative 5 times what? We'll go back to negative 20. Negative times what makes negative?
Positive 4.
Plus 4, huh? Plus 4, because negative 5 times plus 4 goes back to negative 20. And that's what I meant by signs change inside. You don't have to memorize that rule. If you just make it work, it'll be right. The signs will change inside. All right, good. But they're testing on that one. So, in fact, let me rewrite it. Number 10, 8x plus 16. And plus xy plus 2y. Okay, so there's the problem. They want me to factor that. This one's going to be a little different. Can you all read that okay? So, first question we want to ask, we always want to ask, what's in common to all 4 terms? Do they all 4 have an x? No. Do they all 4 have an 16? No. Do they all 4 have a y? No. 16 doesn't have an x or a y. Is there like some number that goes into all 4 of them? Well, no. The x, y has no number in the front at all. Just understood 1. No. So notice there's nothing that all 4 of them have in common, right? I can't do like a big parenthesis and put something in the front because there's nothing in common to all 4 of them. Well, what am I going to do then? What do you do when you got 4 terms? And so step 1, nothing in common to all 4. There's nothing in common to all 4 terms, is there? So what does that mean? Step 2, so that will, let me write what that means. That means skip the one big parenthesis. You're not going to have one big parenthesis on this one. That's only when they all have something in common. They don't. This is new here. It's a little different. So what do you do then? I can't do the one big parenthesis thing because there's nothing they all 4 have in common. So what do I do? Has anybody done these before? You remember? What am I going to do? Yeah, 2, 2. You do a 2, 2. Instead, so that would be step 2 here. Step 2, 2, 2 split. So it's called grouping. You make 2 separate groups. Since we can't do all 4, right? There's nothing in common to all 4. They don't all have an x or y or whatever. Just do the first 2. Just pretend the whole problem is just 8x plus 16. What could you do with just those first 2? What do they have in common? 8. Yeah, they're easy. They have 8. That'd be x plus 2, right? And then do just the last 2. What do the last 2 have in common? Just those 2. Yeah, they both have a y, x plus 2. And bring down the sign that's in the middle. That matters. It's real important. So far, so good? So I did just the first 2. They had 8 in common. Just the back 2 had y in common. Now, can I do more? You know how you want to look at it? Let me help you with how you visualize it. Pluses and minuses outside of parentheses, this guy in other words, is your separator. So you want to visualize this. You want to be looking at this thing as this term and that term. Those are the 2 things you want to be kind of looking at. And then ask yourself what we've been asking ourselves all night. What do they have in common? What do they both have the same? Well, that parenthesis x plus 2. That's the monkey or whatever. That's what they both have the same. So what do we always do? What's the pattern when 2 terms have something the same?
We take the same part and put it in the front, remove it, start a new set of parentheses, bring down the others. Done. That's the answer. Everybody see that last step? Right? Because they both had a parenthesis x plus 2, so I put it in the front. When they both have something the same, you put it in the front, one of them. That could, a lot of times I get good questions. Susan goes, Mr. White, there's two of them and then there's only one of them. And my answer is, yeah, that's always what we do. That's the pattern for factoring. Even look up the y's. See, there were two y's and then there was only one. That's what factoring always does. That one could go back to two, distributed. That's always the pattern. So it's not any different here. Everybody see that? The 2x plus 2 is 1. Because that 1 can go boom and distribute, couldn't it? That's what we're always doing.
So that's important for it to be first?
Instead of you mean at the back?
Yeah.
Doesn't matter at all. Good question.
I didn't think about that. Yeah, and the test we'll take in a few weeks is multiple choice. So that's a good question. This is the same. I'll say or. It doesn't matter what order you put them in. Either way, you totally switch the parentheses. It's totally the same. Does that make sense? Notice when we're done that all the pluses and minuses are contained. You see that? They're all in parentheses. Whereas up here, this plus sign was loose. It's like horses. Horses need to be corralled constantly. Do y'all have horses? No. Who has horses? Crazy people. I used to have more than one. I still have one left because I've got insane daughters who think horses are the greatest thing in the world. And it's craziness. It's insanity. I don't know if you ever... They have cost me more money than the horses have. The horses cost money and they're nothing but trouble. But I did learn one time, Lizzie told me to hold the horse rail and she ran off to do something. And the crazy beast lifted its head and pulled away and then walked out of the gate. And Lizzie came back and said, Dad, where's the horse? I went, I don't know. The crazy thing pulled the reins and she said, Dad, it's out of the corral. It's going to run. So I learned that day that horses must be corralled. So if that helps you remember, pluses and minuses, we're not done until they're all corralled. They all have to be in the parentheses. You're not done factoring until they're in there. So you know at this point you got more work to do, like we just did. So yeah, so try that. Here's the problem. So do first two, last two. First two, last two. You're not done until all the pluses and minuses are contained inside parentheses. So first two. Take out what's in common just for the first two. What did just the first two have in common? M. They both have an M. That's it, huh? So those first two, we'll bring it down here. Take an M out for just the first two. That's what grouping means. Two separate groups, two split. Take an M out of just the first two. And then do the back two. Oh, there's back two have nothing in common, do they? I need to show you about that. Yeah, you take out a 1. When they have nothing in common, you take out a 1. I'll show you. So the first two have M. So let me finish that up first. That'd be 4M squared plus, what is it, 5N. That good? For the first two. Yeah, now the back two, these guys have nothing in common. Let me write a note. When nothing in common... For when you're doing the 2-2 thing anyway. When you're doing the 2-2 thing and there's nothing in common, take out a 1. Because they always have 1. 1 goes into everything, right? So you take out a 1. Everybody see? That's true. It seems kind of silly. But it's true. 1 times that and 1 times that. That would go back. See how it's true? Now, can I stop here? Am I done? How do you know you're not finished? You got the loose horse, right? Pluses and minuses have to all be contained when you're done. So you have one more step. And not only that, it tells you got one more step, but it tells you how to look at it, doesn't it? It tells you, hey, you should be looking at this and that, because the pluses and minuses outside parentheses are the separators, aren't they? So this and this, what do they both have in common? The big old parenthesis 4m squared plus 5m. So you remove it, put one of them in the front. That's the pattern we've been following all night. Start a new set of parentheses. Bring down the leftovers. M plus 1. That's why that 1 became important, because it ends up being there and part of the answer. We're done. All the horses are content. Is that good? Questions on that? All right. That's a good chunk of it if I could. So let's try that. So 4 terms up there. Same thing, first 2, last 2. Feel free to compare with those around you if you want, so you can get the same thing. Okay, how are we doing? So, first 2, what do just those first 2 have in common? 3 and x, yeah. So we're doing the 2-2 split here, right? So first 2, last 2. There's 4 terms, 2-2 split, first 2, last 2. So what were 3x times x? 3x times minus 2y. Good for thank you. Good so far. Good for the first 2. Now, what about these back 2? 4 goes into both of them. Now, no, what's the sign in the middle? Negative. That's got to come down. That's really important. So don't lose that. That's super important. 4 now. Remember, whenever you factor negative in the front of something, what's going to happen to the signs inside? They're going to change. That plus is going to become minus, which is perfect because it's got to match the other one anyway. Do y'all see that? Let me write it. X, right? Minus 4 times 4. Well, that's not x. I said x and wrote 4. Try that again. X minus 2y, right? Because negative 4 times negative 2y goes back to plus 8y. It's right, isn't it? Do you see that? Negative times negative goes back to positive. And that produces a match. We've got to have a match or we can't go forward. We've got to have these identical. Same sign, same everything. On that, yeah?
Can you explain again how the second parentheses, how it's not just 4x plus 8y? I mean, how you did how the x minus 2y became negative instead of positive.
Yeah. If that was plus, like that, then let's try multiplying. What would minus 4 times x be? Well, that'd be good, minus 4x. And what would minus 4 times plus 2 be? It wouldn't be positive 8y, would it?
Right.
You see how it only goes back correctly if it's minus. So that's why it has to be minus, because in the end, it's got to go back to be the same thing. That makes sense there? And now, are we done here? How do we know we're not done? Got the loose horse, right? Minus, and that's also our separator. Tells us how to look at the thing. And so we say, okay. So we get this term, separator, this term. What do they both have? X minus 2y. They've got to match, so it makes sense. Start a new set of parentheses. Bring down the leftovers. 3x minus 4. We're done. All the plus and minuses are contained. Bless you.
Thank you.
If you were to FOIL this out, you might remember FOIL. If you were to FOIL this out, it would go back. That's what we just basically unfoiled, is what we did. Questions on that?